Well, howdy there, Internet students. Mr. Hermanson again. We're doing lesson 9-2C. Today we're going to focus on formulas and how you use those. And in the world, there are all kinds of formulas. Almost everybody who has a job has some formula they use all the time. One thing you might use is if you go to a different country, usually the temperature is in degrees Celsius, but us Americans use this thing called degrees Fahrenheit. And so it'd be nice if you had a way to convert the temperature so that when you look at the forecast, you can figure out accurately what the temperature will be in Fahrenheit, which you're used to. So if you saw, well, just some rules of thumb here. In Fahrenheit, you freeze at 32 degrees, at least at sea level. And in Celsius, it's at 0 degrees. And then when you get really hot, in Fahrenheit, the point at sea level that water boils is 212 degrees Fahrenheit, and that is the same as 100 degrees Celsius. So as you can see, a temperature like 100 degrees in Celsius is really warm. It's really warm in Fahrenheit too, but it's something we can actually stand and live with. But in Celsius, if it was 100 degrees, you would not survive very long. Anyway, so we're going to use a rule to predict. So here's how it works. You multiply the degrees in Celsius by 1.8, and then you add 32. Okay, this is a formula. This number right here, 9 divided by 5, is the same as 1.8. So if you would rather use a decimal, you can do 1.8 times C plus 32. Now remember that when you see this, a number next to a letter, that means to multiply there. And also remember, multiplication comes before addition when you're figuring things out. So here we are converting 20 degrees Celsius to degrees Fahrenheit. So if the temperature in Canada says 20 degrees Celsius on the bank thermometer, that means it's 68 degrees outside for the temperature that you're used to. Okay? So let's let you do two problems. Go ahead and find the Fahrenheit equivalents of 33 degrees Celsius and 15 degrees Celsius using the formula. All right, here's what I got for those. And here's how I did it, just in case you didn't do it right. To find the degrees Fahrenheit, you take 1.8, multiply it by the degrees Celsius, 33, and then add 32. That's how I came up with this 91.4. All right. Just a quick question, is the relationship between Celsius and degrees Fahrenheit proportional? Are the ratios equivalent? Would the graph go through the origin? And the answer to that question is no, because of this adding 32. That 0 degrees Celsius is the same as 32 degrees Fahrenheit, so that the point 0, is not on this graph. But it is linear, it does go up by the same amount, it goes up by 1.8 degrees Fahrenheit for each degree Celsius. All right. Go ahead and use the formula to do these. I'm going to do one for you. I'm going to show you how to get started on this when you're converting Fahrenheit to degrees Celsius and you're using this formula. And again, we can use 1.8 there instead of the 9/5. I think you'll like that better. So if you have a Fahrenheit, that is your answer, your output, and the Celsius is your input, so you would actually have to solve this equation. Use your backtracking method, your your flow chart diagram to do that. All right, go ahead and do those 4 problems. All right, here's what I got for those. On this last one, I'll just remind you how to do this. So the first thing you're going to do is multiply your input by 1.8. Then you're going to add 32 to that, and you're going to end up with 50 degrees Fahrenheit. So we're going to go back by doing minus 32. That gives us 18. And then we're going to divide that by 1.8, and that gives us 10 degrees Celsius. All right, most pastry is made from flour shortening, like butter and water. There are different types of pastry. In short, pastry, the relationship between the amount of flour F and the amount of shortening is given by the following formula. The shortening equals 1/2 of the flour. Or another way you can do that is the flour divided by 2. I think I like that one better. You decide. Okay, so Alice wants to make lemon tarts with a short pastry using exactly 800 grams of flour. How much shortening should she use? So the shortening is the amount of flour divided by 2, which is 400. All right, now Daryl wants to make short pastry for cheese sticks, but he has only 250 grams of shortening. So in this one, the shortening comes first. The shortening is equal to the flour divided by 2. Now you have to work backwards on that one. And you don't always have to make out the chart. You should know that if there's only one operation and it's divided by 2, the way you solve that is you multiply. So the flour equals 250 times 2, which is 500. All right. Go ahead and I'll let you do this one. Now, again here, this is a fraction 3/4. You could change that to a decimal. And I'm okay with that as long as it's not a repeating decimal. When you do 3 divided by 4 and change that into a decimal, it's 0.75. So that's a total really nice decimal number. So you could do shortening equals 3/4 F if you like. Okay, so go ahead and see if you can answer this question. I got 150. How about you? All right. So which type of pastry, short or flaky, needs more shortening for the given amount of flour? Check your answer by testing the amount of shortening for 2 amounts of flour. Okay, so if you have 0, the short pastry would be 0 divided by 2, which is 0. The long would be 3 times the amount of flour. 3 times 0 divided by 4, which is also 0. Go ahead and fill that chart in for the rest of it and ask those questions, answer those questions. All right, again, I used 0.75 times F for this one here, but that's up to you. And here's what I got for those numbers. I'll just do one example here. I did 200 times 0.75 to get this amount of flour. The other one is pretty easy, just divide the flour by 2. All right, is the relationship between flour and shortening proportional for the short pastry? So this one you're going to say yes, because 0, 0 starts at the origin and it goes up by 50 every time. Is the relationship between flour and shortening proportional for the flaky? You're going to say yes. You have 0, 0 again there. Okay, and these go up by 75 every 100. So yes, same reason. Graph both on the coordinate plane. I'll get you started here. Obviously they start at 0, 0. My blue is the flaky pastry, so 0, 0. I got a point at 175. So I'm going to go over to 100 up to 75. Then 200 goes to 150. 300 goes to 225, 400 goes to 300, and 500 goes to 375. Okay, so there's the line for the flaky pastry. Now the short pastry, we have these points. I'll do those in red. We have 0, 0, 150, 200, 100. So remember, the output is half of the input. So 0, 0, 150, 200, 100, 300, 150, and so on. And that's that line there. All right. Do these look like proportional graphs? Yeah, they're linear. And so they're a nice straight line, and they start at 0, 0. So that would be proportional. Okay. In 6th grade, you found the measures of the interior angles of several polygons. What is the sum of the interior angles of a square? That one's pretty easy. Each corner is 90 degrees. 90 times 4 is 360. Same with a rectangle. There's 490 degrees in a rectangle. And actually, for any quadrilateral, there's 360 degrees. Okay, so now that we know there's a total of 360 degrees here, if we add up all of these, our missing x plus, if we add all of these up, has to equal 360. So I'm going to add the 48, 157, and 55. And that's 260. And then I'm just going to backtrack. Since this says add 260, I'm going to minus 260 from 360, and that equals 100. So the missing angle is 100 degrees. All right, the formula for the area of the circle is the area equals pi r squared. Remember that pi is an irrational, never-ending, never-repeating decimal number that is equal to the circumference of any circle divided by its diameter. So that looks like this here, circumference divided by diameter. The pi button on your calculator is one approximation of pi. List other approximations of pi. 3.14 is another one. 22 over 7 is another one people sometimes use. So what is the value of pi r squared for r equals 5.6? Go ahead and answer that question. I used 3.14 for pi, and I got 98.4704. I'm going to just round it at 47 there. Okay. Why is the order of operations important when finding the area of a circle? You don't want to do pi times r first and then square it later. If there were parentheses like this, you would do that, but that isn't what we have. We want to do the 5.6 squared first, and then we're going to multiply that by pi. All right. Buck's Pizza makes pizza with a diameter 12 inches, which costs $7.50. Use the formula to find the area of a 12-inch pizza. Go ahead and try to answer these questions. See if you could figure out which is a better buy and why. All right, so I think it's better to buy the bigger pizza. And here's my math here. What I did is I took the cost, which is $7.50, and I divided that by the area, which was 113.04. And that told me the price per square inch. So it's about 6.6 cents per square inch, where the bigger pizza, doing the same math, gives me about 5.5 cents per square inch. So Buck's smallest round pizza has an area of 78.5. Write the equation that you would need to find the radius of the pizza. And I'm going to use 3.14 for pi, but you would do that times radius squared. Now when you solve this, you're going to backtrack. And so I'm going to remind you how to do that. You end up, there's two steps here, and you end up with an output of 78.5 by doing your radius. You start by squaring that. So I'll just write r squared for that. And then you multiply that by 3.14. So going backwards, you're going to divide by 3.14. And then the way you want to do a second power is a square root. So you're going to do square root to get the answer. Go ahead and give it a shot. Dividing 78.5 by 3.14 gives you 25. And when you do the square root of 25, you get r equals 5. Nice work. Go ahead and summarize that and try the practice problems. And if you have any issues, message me. Other than that, I'll see you soon.